Hello and welcome. Today, inshallah, in this session, we are going to discuss the electronic configuration. What does it mean exactly the electronic configuration of the element inside the periodic table? To understand that, let me give you an example. Each element of the periodic table, like for example, Na is a symbol for sodium element. Now, each element in the periodic table has two numbers, the atomic number and the mass number, like the sodium here. Over time, sodium has 11 atomic number and 23 mass number. What does it mean exactly, the atomic number, which is 11? It means the number of electrons and the number of protons. This 11 means that the number of electrons inside the sodium atom is 11, and the number of protons inside the sodium atom also is 11. Now, 23, it's the mass number. It means that the number of protons plus the neutrons together equals 23. Okay, so this is what does it mean exactly, the atomic number, which is 11, and the mass number, which is 23. Now, what is that related to the electronic configuration exactly? Now, let's say that the sodium atom right now has 11 electrons, like that. Na has 11 electrons. Now, how can we distribute those 11 electrons inside the atom of the sodium? What does it mean? If we draw the sodium atom like that, the atom of the sodium is just like nucleus in the center here. Okay, this is the nucleus. Around the nucleus, there are the energy level like that. Sorry for my drawing right now, but just stay with me. This is the level number one around the nucleus. Now, the first level here, this circle here around the nucleus, we call it level, energy level. Okay, we call it energy level, or we call it shell. Energy level or shell. What exactly the energy level or the shell? It's just the places that the electrons orbiting around the nucleus inside it. We call it energy level or shells. Okay? Now, the maximum number of the level inside any atoms inside the periodic table is just up to 7 electrons. Up to 7 energy levels or up to 7 shells. Okay? So, how can we distribute those 11 electrons around the nucleus here inside the shells? So the first one all the time take 2 electrons. Okay, the first level here of the atoms all the time take 2 electrons like that. The second one, the second energy level, all the time take 8 electrons. So we just draw 8 electrons inside this shell. Okay, like that. The third shell here around that will take just 1 electron. 1 electron. Why it takes 1 electron? Because it will remain for us 1 electrons from the 11. The first shell take 2. Second shell take 8. The third one, it will remain for us from this 11, just 1. So the third one will take 1 electron. What we have did right now, it's called the electronic configuration, distributing the electrons of the atom inside the atom itself. So the electronic configuration for this one is going to be 2, 8, 1. Okay, 2, 8, 1. Very good. Now let's take another example. If we have for example potassium. Potassium has 19 atomic number. How can we distribute the 19 electrons here of the sodium atom inside the atom? We just draw the atom like that here, as you see. Around the atoms, there are the shells, like that. Around the nucleus, sorry, there are the shells here, as you see. Now, how can we distribute the 19 electrons inside inside the shells here? The first one all the time take 2, as we know. Second one take 8 electrons, as we have here. Now, the third one also take 8 electrons. If it's available 8, so it will take 8 electrons here. Okay? The last shell here we have will take just 1 electron. Okay? Will take just 1 electron because it will remain for us 1 electron. So the electronic configuration for that right now is gonna be 2, 8, 8, 1. 2, 8, 8, 1. Okay? This is what we call it the electronic configuration for the electrons. Now, also the electronic configuration for the electrons determine exactly where exactly the atom or where exactly the element inside the periodic table. Determine the group and the period of the periodic table. How is that possible? Now, this potassium here has electronic configuration 2881. It means here you have 1 electron in the last shell. So potassium in group number 1. Here you have 4 shells. 2881. It means you have 4 shells, 4 numbers. 4 numbers, it means you have 4 shells. So potassium in period number 4. So what determines the group and the period of the element inside the periodic table, just the energy level, the valence electrons or the electrons in the last energy level determine the group number of the element, which is 1 in case of potassium. So potassium group number 1. And also the 4 shells, the number of the shells, 2881, it means that the potassium here has 4 shells. It means that the potassium located in period number 4 inside the periodic table. Okay? This is how can we use the how can we do the electronic configuration for any element, and how can we use the electronic configuration to determine the position of the element inside the periodic table. Okay? Thank you for watching and have a good day.